Hi, second year students, it's Math with AUB. Let's continue our journey where we have left. We have done integration by parts from 1 to 6. Now from 7 to 12, total questions are 80. Part 3rd will be the final. Integration by parts, there is always a dispute or brawl, strife, what to select first one. First one. Normally, the accepted routine is I let rule to be taken the first one. Inverse, trigonometric function or hyperbolic function, logarithmic function, third one, algebraic function, fourth, trigonometric and exponential. I have given you the clue. They are interchangeable. This make no difference. This make no difference. To making life simple, keep two things in mind. Take the first one whose integration is not known. Take the first one whose integration is not known. Let's see here. X integration of x we are familiar. Second verse, its integration is not known to us. So it is the first one. It is the first one. Let's reconcile this with that one. Inverse function to be taken first. Here is the inverse. These two concepts are parallel. Take the first one whose integration is not known. Take the first one whose integration is not known. Number one. Number two, if integration of both function is known, if integration of both function is known, as is the case here, so does here. Integration of x square x cube over 3, integration of e raised x is e raised x. Here, integration of x is x square 2 and cos is minus sign. Integration of both function is what to do? Take the first one whose derivative decreases or diminishes. Look at this. X square, first derivative 2x, then 2x is no more. Here, take first one as x. Differentiation of x is 1, x is no more. Let's reconcile this with that. After inverse, no logarithmic, then we have to switch over to algebraic function. That's x square x. That's x square x. Here again, take the first one whose integration is not known. If you reconcile with this one, there is inverse. Mark my two sentences. Take the first one whose integration is not known. Integration is not known, not known, not known, not known. So n and r inverse must be the first, as according to Eilert rule. Second, if integration of both function is known, take the first one whose derivative decreases or diminishes. Whose derivative decreases or diminishes. These are the 2 points. They have been branded, collaborated, sugar coated as Eilert rule, as Eilert rule, as Eilert rule. It is nothing but take the first one whose integration is not known. If integration of both function is known, then take the first one whose derivative decreases, diminishes. Okay, let's start. Question number 7 is x sec inverse x dx. Integration of sec inverse is not known, it must be the first. Simple rule is that r, switch over to this one, take inverse as the first function, write it as sec inverse x times x dx. This is our second, applying by parts. This is our u, this is our v. Sec inverse x, same integration of second, integration of x with respect to dx minus overall integral. Differentiation of first, differentiation of sec inverse x with respect to x and integration of x with respect to dx. It is tantamount to first same, integration of second minus overall integral, differentiation of the first function, integration of the second function. Sec inverse x, integration of x is x square over 2 minus whole integral. Differentiation of sec inverse x is 1 over x times x square minus 1. Here integration of x is x square over 2 dx. First same, integration of x is x square over 2. Differentiation of first, differentiation of second inverse x is 1 over x times x square minus 1. Integration of second is x square over 2. Simplify, make the life simple one. Here remains x, and we have done. We are almost done. 1 upon 2 x square sec inverse x. Here write 2 outside. 1 over 2. What left? What we have left with is x dx over x square minus 1. Differentiation of x square is 2x. Differentiation of x square is 2x. Function derivative, function derivative, function derivative. I have told you several times, function derivative works wonder for you. Works wonder for you. Here, let me write same 1 over 2 x square sec inverse x minus 1 over 2. Shift this into numerator because it has overall power 1 over 2. It has overall power 1 upon 2. Overall power 1 is our exception. Overall power 1. If function is in the denominator having overall power 1, it is the case of ln. It is the case of ln. It is not the possibility here. Power is overall 1 over 2. Shift this one into numerator, making the exponent negative times x dx. Differentiation of x square is 2x. Differentiation of x square is 2x. Here is x. Deficiency of 2. Just simply multiply and divide. Multiply and divide by 2. Multiply as well as divide as well as multiply. We have compensated the deficiency. Now it's our function. Why? It's our dy. Function derivative, function derivative, function derivative, function derivative. Add 1 into the power of function and it's our integration. 1 over 2 x square times sec inverse x minus 1 over 4. Add 1 into the power minus 1 upon 2 plus 1. It will become positive 1 over 2 dividing with the same plus c. Here remains 2 and that's our answer. That's our answer. We have 1 over 2 x square times sec inverse x minus 1 over 2. Let me write instead of 1 upon 2 square root plus c. Square root plus c. I have done nothing. Now we are a little bit mature. Function derivative, function derivative, function derivative. Add 1 into the power of function. Forget about the rest. Function derivative, add 1 to the power of function and forget the rest. Forget the rest. That's our overall integration. Instead of 1 upon 2, I have written 1 over 2 times root x square minus 1. Take the first one whose integration is not known. That sec inverse, its integration is not known. If you reconcile with this Euler rule, inverse to be taken as first. So we have did so. We have done so. We have done so here. Okay, cool. Moving towards question number second, we have done several questions having ln. Second question is ln. Check the frame. Is it good? Is it good? Okay. 8 ln 2x plus 3 dx. We have to generate another function. One is always our helping hand, one is there. Take the first one whose integration is not known. Integration of ln function is not known. Reconcile with this Euler rule of if inverse is not present, then second priority is ln is there. So writing it first, second, integration of second minus whole integral, differentiation of first, that is ln 2x plus 3 times 1 dx. U same, integration of v, differentiation of u, integration of v. Integration of 1 is x, so I have ln 2x plus 3 times 1x minus differentiation of this one. Ln means whatever is with ln, write in denominator. Whatever is in the denominator, differentiate in numerator. 2 times x is 1, 3 is 0. That is strategy for L. Ln means 1 over whatever the function is. Whatever the function present in the denominator, its differentiation must be written in numerator. Integration of second is x dx. So we have x ln 2x plus 3 minus 2 times x divided by 2x plus 3 dx. Here comes another situation to be discussed with you. That is, they have the same power, denominator and numerator have same power. It is the case of synthetic division. Synthetic division. Both have same power, same degree. Our degree of numerator is greater than denominator. If degree of numerator is greater than denominator, it is the case of synthetic division. As well as if they have equal degrees, still it is the case of synthetic division. Synthetic division is the cumbersome process, but you are familiar. Let me give you a good tip in that case. How to handle this? we have to manage the same function here in the numerator and our numerator remains same. We need denominator as it is replica in numerator and numerator also remains same mathematically. So what we do here? Add as well as subtract 3. Add as well as subtract 3. Then separate divide with 2x plus 3. With this one, it is R1 integration of 1 is x. Here, it's function derivative and situation of ln. Situation of ln. Divide this same. This one 2x plus 3 synthetic division. We have done with synthetic division. Whatever is the numerator, 100% we require this in numerator. Sorry, whatever is denominator, we need 100% in numerator and numerator also remains intact. What we have done? Plus 3 minus 3. Mathematically, it's equal to 2x. It's equal to 2 and x. Okay. So I have it's same x times ln 2x plus 3 minus separately divide 2x plus 3 divided by 2x plus 3 dx and minus 3 times dx. Okay, let me write 3 here. 3 dx overall 2x plus 3. Look at this. Here we have 1. Here we have 1. Integration of 1 is x. Integration of 1 is x. Here function derivative situation, differentiation of 2x is 2. Differentiation of x 2x is 2. Differentiation of 2x is 2. There's deficiency of 2 divided multiply by 2 and settle down the rest. Settle down the rest. So we have x times ln 2x plus 3 minus we are left with 1 dx. Here 3 outside dx over 2x plus 3. Differentiation of 2x is 2. Differentiation of 2x is 2. Multiply as well as divide by 2. Multiply as well as divide by 2. Multiply as well as divide by 2. Integration of 1 is x. Integration of 1 is x. This is function in the denominator having overall power 1. Function having in denominator having overall power 1. And differentiation in the numerator. Function derivative, function derivative. If function is present in the denominator having power 1, it is case of ln. We have discussed several times. Let's see one more time. We have x ln 2x plus 3 remains same minus integration of 1 is x here 3 over 2. Function derivative. Ln whatever is the denominator, it's our answer. Just multiply negative sign. We have x times ln 2x plus 3 minus x minus plus 3 over 2 ln 2x plus 3 and c. Let me repeat this one. This is our case of synthetic division. We have 2 times x 2x over 2. If degree of numerator and denominator they are same, it's case of synthetic division. If degree of numerator is greater than denominator, if degree of numerator is greater than denominator, synthetic division still you have to apply. If they both have degree same, so does here. We have to apply synthetic division. How to manage this? How to negotiate this? This is 2x plus 3. We have 2x. Add and subtract 3. Add and subtract 3. And we have done with synthetic division. Separately divide 2x plus 3 with this term as well as this. Cancel out 1 integration is x. Function derivative, there is definition of 2. We have divided as well as multiplied with 2. Function derivative, function is in the denominator having power 1. It is case of ln we have done so. X ln 2x plus 3. Integration of 1 is x. Function derivative, function having overall power 1 in denominator. It is case of ln 2x plus 3 plus c. Okay, good. Moving towards the case where the integration of both function is known, then we have to take the first one whose derivative decreases or diminishes. So let me write first data, that is x square times ax dx. No, integration of both function is known. Then if we take first one this e raised x and so on. What about derivative of this one? X square 2x then 2 then x no more. X differentiation of x square is 2x 2 no more. So it is Ru, it's Rv. Let's reconcile this fact with Eilert rule as usual. There's no inverse, good, no logarithmic. Then we have to switch out to algebraic function, that's x square, x cubed, whatever the case is. So first same, x square, integration of second is x dx minus overall integral, differentiation of x square with respect to x, and integration of second ex dx. We have differentiation of ex, same, sorry, integration of ex. I have said differentiation. Integration of ex is also ex. Differentiation of x square is 2x. Integration of ex is also ex. Again by parts here. From x square to 2x, then no more x. Again by parts. This is our first function. This is our second. This is our u, and this is our v. Again by parts, we have x square ex minus u, same, integration of second, that's ex dx minus whole integral, differentiation of 2x with respect to x, and integration of second, that is ex dx. What we have left with, sorry, x square times ex minus 2x, integration of ex is only ex, differentiation of 2x is 2, integration of ex is ex. Here integral prevails, integration of ex again ex, integration of ex again ex, just multiply the minus symbol and manage the show. So we have x square times ex minus 2x ex minus plus 2, let me write ex, integration of ex again ex, integration of ex again ex. We have x square ex minus 2x times ex plus 2 ex plus c. That's our answer. That's our answer. There. That's if there is x cube, we would have applied integration by part third time as well. Power 4 times, and so on and so on. Direct trick for them. It's really very. It's really very. They will be discussed in some other relevant time. What about this? Integration of both function is known. Then we have to take the first one whose derivative decrease. That's the x. That's the x. Reconcile with the Eilert rule. Inverse logarithmic. Then algebraic same x we have to take in that case as well. Okay, moving towards question number 4. We have x cos dx. X cos dx. Making the life simpler, our first one is x. No more inverse, no more logarithmic. Then we have to prefer algebraic. Or if integration of both function is known, then take the first one whose derivative decreases. If we take cos minus sine, and so on. What about this x? Differentiation of x is 1, then x is no more. U, this is our u, then this is our v. U, integration of v, integration of second minus whole integral. Differentiation of x with respect to x, and integration of second cos x dx. X integration of cos is only sine. Integration of cos is only sine minus differentiation of x is 1. Integration of cos is only sine. Here's integral. Integration of sine, one more, only single function, lone function. Integration of sine is negative cos. X times sine x minus integration of sine is negative cos. Negative cos plus c. Minus plus, and it is our answer. It's our answer. Moving towards question number 11. There is a single function having inverse. It must be taken first according to Eilert rule, or applying simple logic. Integration of cos inverse is not known, so it must be taken as first, as u. Okay, we have cos inverse x, second function is x dx. That's our u, that's our v. Let me explain to you again. If there is only inverse, take the first one whose integration is not known, that's our cos inverse. Moving towards Eilert, inverse to be taken as first. Here it's our u. In both cases we have decided the same factor. First same, integration of second minus differentiation of first, that is cos, differentiation of cos. Integration of second. First same u, same differentiation of v, differentiation of u, integration of v as usual. We have cos inverse x, integration of 1 is x minus. Differentiation of cos is negative 1 over 1 minus x square. Differentiation of cos inverse is minus 1 over 1 minus x square in root, and integration of 1 is x. Negative, negative, positive. We have x times cos inverse x plus x over 1 minus x square dx. Our life is simple enough. Function derivative, function derivative. Differentiation of negative 2x is minus 2x. Differentiation of negative x square, differentiation of negative x square is negative 2x. So here is deficiency of only minus 2. We can manage x cos inverse x plus shift this function in numerator because it hasn't power 1. If power is overall 1, then it is a case of ln. Otherwise, whatever the power is, switch over in numerator. Minus 1 over 2x dx. Making the life simpler, differentiation of minus x square is minus 2x. Dividing and multiplying by minus 2. Dividing and multiplying by minus 2. Dividing and multiplying by minus 2. I have here it is x dx. Differentiation of negative x square is minus 2x. Differentiation of negative x square is minus 2x. So I have divided deficiency of minus 2. I have compensated by dividing and as well as multiplying. Now it's our simple function derivative, function derivative, function derivative, function derivative. Add 1 to the power of function, forget the rest. That's our answer. We have x cos inverse x minus 1 over 2 minus 1 upon 2 plus 1. It is our positive 1 upon 2. So I have 1 minus x square raised 1 over 2 dividing with the same plus c. These two cancelled out. So we have x times cos inverse x minus, instead of 1 upon 2, let me write, sorry, I might be out of frame. Let me write this step again. X cos inverse x, instead of 1 upon 2, I can manage 1 minus x square plus c. It's my answer. It's my answer. It's my answer. So is the 12th question. 6 more are remaining in next frame. Tan inverse x. Take the first one whose integration is not known. Take the first one whose integration is not known. Or switching over to Euler rule, it guides us. You have to take first one as inverse, ln, algebraic, trigonometric, and exponential. If we take a glimpse of this question, there is inverse. There is inverse. So first possibility is there. Or according to simple my suggestion, take the first one whose integration is not known. Take the first one whose integration is not known. Obviously, that's tan inverse x. Either to take this path or direct whatever suits you. According to Euler rule, inverse is the first. Second one is our helping hand by parts. First same, that's our u, that's our v. First same, integration of second minus whole integral. Differentiation of first, differentiation of tan inverse x times integration of second, that's 1 dx. We have tan inverse x, integration of 1 is x. Integral, differentiation of tan inverse x is 1 over 1 plus x square. 1 over 1 plus x square. Differentiation of x is 1. We are cool now. X tan inverse x, look at this. X dx 1 plus x square. Differentiation of x square is 2x. Differentiation of x square is 2x. So here is the deficiency of 2. Look at this. Overall power is 1. Overall power is 1. Overall power is 1. It is case of ln. It is case of ln. It is case of ln. Compensate the deficiency. Compensate the deficiency by dividing and multiplying. X tan inverse x minus 1 over 2 divide and multiply by 2. Power is overall 1. I am writing for you in order to give you clarity. Power is overall 1. It can't be shifted into numerator and adding 1. This is the exception. 1 to be added in that. It's exception. No. It's case of ln. It's case of ln. So does here. It's our function. It's our derivative having overall power 1. Function is the denominator. It is situation of ln. It is situation of ln. So our answer is x tan inverse x minus 1 over 2 ln whatever the function present in the denominator. You can leave here, you can leave here, or you can utilize the tiny identity of logarithmic. Its coefficient can be converted to power. Its coefficient can be converted to power. We can write as x tan inverse x minus ln 1 plus x square raised 1 over 2 plus c. 1 over 2 means root. It can be written as x tan inverse x minus ln root 1 plus x square plus c, whatever the case is. You should have familiarity from this fact. This coefficient can be converted to power by tiny property of log. Ln a power b is b times ln a, b times ln a. So we can make power coefficient. Our coefficient can be converted to power by virtue of log property. Log property, Napier log, it is the case. Extend, you can leave here, or you can leave here. You should have familiarity from where comes or occurs this 1 upon 2 or root. It's our answer. It's our answer. Okay, 6 questions are remaining. Inshallah, we are about to complete in tomorrow's frame. It's my tiny effort to you guys to give you clarity on integration. It's all by itself. Next.